agora está com turismo. Não, eu não tenho. Ótimo,
aquele negócio de perder para deixar na lá. Ele sabe que os trabalhos mais.
inverte mais.
Mas por que você tem que inverter ou por que não só? Aquele negócio de inverter.
Tem, dá pra vai se falar.
Great questions. The reason it will turn reddish, and it's still very subtle to the naked eye, is that the Earth shadow is not a black shadow. It's a red shadow, and it's red because there is a ring of our atmosphere. All of the world's sunrises and sunsets have to take the correct exposure to include the bright part of the moon, and the sunlit section of the moon before totality is so bright that it will underexpose, and your eyes do the same thing, underexpose.
And that full color come into view. Does that sound like a good plan?
Yes, it sounds like a great plan. And one more thing to look for is that since we have Mars in the sky to the upper right of the moon, just before totality, when we have one last little tiny bit of white sunlight on the moon,
we're going to be doing sort of bite-sized astronomy educational nuggets every week that the teachers can use in their classrooms to get ideas for activities associated with the wonderful images and celestial opportunities that we have, and also for students of all ages to learn a little bit more about the nighttime sky on their plate already to get a bit of a leg up with astronomy education, because we're going to have some prepared modules and prepared segments that they can sort of dip into and use to augment what they do in the classroom, or to supplant some of the old things that they used to do in the classroom. SLU and its robotic telescopes are an absolutely wonderful resource that everybody, from amateurs to professionals to just enthusiasts, should dip into.
Well, that's another aspect, actually, that we haven't discussed tonight, just as we see this wonderful live image.
It's from the perspective of what could you do with it in the classroom? Are there any activities you could do? What's really going on? And I will tell you, I was listening in before to your discussion with Bob. I could listen to him read the phone book. He's got such an encyclopedic knowledge, and you know, we're going to basically use some of the information he was talking about, but put it more into how a teacher could use it in the classroom context.
Is also rotating in the same direction. You have to have that shadow moving eastward, but move northeast or move southeast, or and sometimes just even due east briefly. So
live when we create the program. So absolutely, wherever you can get SLU, you can hear my dulcet tones babble on about astronomy.
Perfect. And of course, the big advantage here when it comes to schools in either North or South America, well, as we say, break a leg. We will still be here as soon as you finish or anything else, so don't worry, and we are looking forward to it. enjoy. This is Michael Narlock, the new SLU educator. This is part of our new SLU classroom program. Over to you, Michael.
Of closest to each other physically in the sky, that happened 12 hours ago before the eclipse began.
What a night we've had here, Bob, at SLU. We've had the live show. We had Rob Manning from the Jet Propulsion Laboratory. We were talking about Mars being its closest to Earth in the last 6 years. And now we're watching these fabulous live images of the lunar eclipse. You're sitting in the Prescott Observatory with Observatory Director Matt Francis generating these beautiful, beautiful images. Now, we are kind of changing our scheduled program here, Bob. I'll probably get in lots of trouble, but we're deciding with our producer tonight that we can't give you a recorded interview while we're getting these fantastic color images of the moon. So we're going to kind of put that back a little bit. We're going to invite Jeff in maybe over the next half an hour sometime. So, Bob, let's go back to what we have been promising viewers all night. Fabulous comets out there to look at, and both Pan-STARRS and Lovejoy are still looking absolutely fabulous at the moment.
They are beautiful. Once every 50 to 20 years, we get what astronomers call a great comet. That adjective sounds like, hey, it's swell, it's great. But that's the actual technical term.
Yeah, it is. Yeah.
And that's the kind of comet that is bright enough to be even seen through the light-polluted skies in cities and urban areas. Well, that's not what we get every year, of course. But thanks to the SLU telescopes, we do see very, very nice comets. And Pan-STARRS and Lovejoy has given us what that nauseating comet failed to give us. And it is an honestly spectacular view. But then as it goes on, red will retreat, and with our eyes, if we're watching it directly, or the SLU equipment will increasingly show the shadow as being black. So we don't have that much longer for this beautiful red part of the eclipse. I hope those who are watching both with SLU and out your window, if you have clear skies, are enjoying a blue star.
Oh, Alicia says, does the moon rotate? Now, this is a really common misconception because we talk about the dark side of the moon, but there's no such thing, is there, of the dark side of the moon?
Not a permanent dark side, no. Just as Earth has a night side and a day side at any given moment, but fortunately for us, no matter where you live on the Earth, it doesn't stay dark, it doesn't stay light. Earth turns just like that. The moon has a temporary dark side, 2 weeks of night, and the other side has 2 weeks a day, but it does rotate. Its period of rotation is 27.32166 days, exactly, and in that period of time, the moon makes one spin. So why is it that when we look up towards the moon, we see the same pattern of blotchy, what they used to think were seas or oceans on the moon, we now know are areas of solidified lava that flowed billions of years ago on the surface. That blotchy pattern, sometimes called chauvinistically the man in the moon.
Do the waves get bigger in the ocean when the moon gets blocked, or do the waves stay the same? Now, this is from Joshua Aguilar. So this is maybe not just the waves, but the tides, best objects in the sky to look at, but only visible.
Eclipse, as we well know, the moon's shadow has tapered to just a very narrow, perhaps 140-mile band, a little ribbon, a little path along Earth's surface, so only the tiniest fraction of humanity. So basically,
more people see a lunar eclipse. So it's kind of common thinking, if you ask anybody, they are far more likely to say, well, I've seen a lunar eclipse, than somebody who's not. So that's why so many of us, including myself, assumed that lunar eclipses were actually more common. So Zara, there is your answer. I'm going to answer the second part of that. And that was, do other planets have eclipses? And they do, but there's also, I've got to bring it back to this. Everybody knows my favorite object, Jupiter. And very recently, over the last couple of weeks, SLU members have been watching Jupiter's Galilean moons as they disappear into eclipse. They fall in. We've got a fantastic image coming up just now. This is one that one of the SLU members took. And it's when one of the moons passes behind the planet. It's called an occultation. the moon is occulted by Jupiter. But sometimes, even when it's come out from behind the planet disk, you still can't see it because it's in the shadow. In other words, it's been eclipsed, just like our moon is eclipsed by Earth's shadow. Then the Galilean moons on Jupiter are eclipsed by the mighty gas giant shadow. And just imagine the kind of view that you'd get if you were on that moon as you came out of eclipse. It would be absolutely stunning. Oh, I'd give anything for that, Bob. Now, Bob, Matt has been giving us some superb images, and one that I saw earlier, I believe, if anybody spotted it and wondered what it was, it's a wider field view, and I believe we saw the star Spica, didn't we?
Oh yes, we saw the star Spica, and I'm telling Matt right now that people have appreciated that. So when you can get that in the field of view, that's absolutely wonderful. I think we have that coming up for you right now.
Yep. So
one of the bluest. Yes, one of the bluest stars in all the sky. Spica is one of the very hottest, bluest stars.
For those who are watching with their naked eye, that is the bright object just to the right, if you will, of the moon tonight, to the right and just a little bit below.
Yes, and in our image, there it is.
There it is.
There it is. So if you're, it's probably, I would say, what's that, Bob? 4 or 5 lunar distances away?
Yes, perhaps that, perhaps not even quite, but yes, just about that. Quite nice.
When you see that star, Bob, you've been saying that it's blue. Why is a star blue? Why are stars different colors?
Well, just as the temperature the temperature really determines it. It's a whole string of things. The more massive a star is, the more pressure it'll have in its core, and the more pressure in the core, the hotter it will burn. So these are hotter, and it's very similar to if you heat up a piece of metal on Earth. When it starts glowing, it'll glow a dull red, and then a bright red, and if it gets hotter still, it'll turn orange, then yellow. And hotter still, unless it has melted already, it will turn white. Notice it's not green. Glowing metal will never turn green, just as there are no green stars. And if the metal had not melted first, it will have melted by then. But if it hadn't melted, it would turn blue. So blue is the very hottest temperature.
Bob, does this give us some sort of idea of where in its life this star is?
Yes, quite so, except that blue stars die in their youth. They never live to be old. So whenever we see a blue star like Spica next to the moon, it means automatically it's a young star.
And by young, what do you mean?
Typically millions of years, tens of millions of years, rather than the
billions.
Exactly.
See, I think what you'll find very quickly, Jeff, the community aspect of SLU is one of the strongest parts. Now, it's been an absolute delight to introduce you this evening to that community, but also to our wider audience tonight. So thank you very much for joining us tonight, and we're going to be seeing you very soon, I hope.
Yes, absolutely. Thank you. And I'm going to, now, when I get off with you, I'm going to walk outside and take one more look at the beautiful moon under our clear California skies tonight.
Take care, Jeff. Thank you very much for joining us. Good night.
Bye-bye.
Now you are back with us. Here we are, SLU Community Observatory. We are watching the live lunar eclipse. This is a total lunar eclipse. It's visible in North America and South America. We just caught the end of it, if you remember, from the Canary Islands Observatory, where the moon was setting just as the shadow of Mount Teide, the volcano, pointed down towards the moon. Now we are starting to see this marked change in the eclipse. Bob, this is that last image suddenly clicked, and there we are. We're kind of very obviously out of the total lunar phase, aren't we?